Okay, Muzaffar, let's proceed ahead with your technical snap for theory of machine. And you are
Thank you,
going for
sir.
assistant engineer post of Jammu and Kashmir, right?
Yes, sir.
अच्छा मेरे को लिंक के बारे में बताओ, लिंक को कैसे डिफाइन करेंगे आप?
Sir, link it is actually a rigid member, sir, which does not undergo deformation under the application of load, sir. Because we want link to be a rigid member, so that there is no deformation in, in it, so that it can transmit the force or torque efficiently, sir.
Okay, so if I give you a belt, is it a rigid member?
Sir, it becomes a rigid when under the application of tensile force, sir. If a tensile force is applied on it. Sir, belt and pulley will yes, belt it yes, sir. I think it's a link.
So, but it is not rigid. Still, it is a link.
Sir, actually, it's a resistant body, sir, not a rigid.
Can resistant
Sorry, sir,
body be link?
No, sir.
Are you sure?
I think so, sir. Because sir, a resistant body is not always a rigid, but it becomes a rigid when we want it to serve a particular purpose. For example, sir, if we want to apply tensile force on the belt, it becomes resistant to it. So it becomes a resistant body, a rigid body, but it is not always a rigid body.
Okay. Okay, Muzaffar, tell me, what do you understand by mechanism?
Sir, mechanism, it is actually an assemblage of linkage, sir, when the motion of one member produces constant or predictable motion in the other member, and the function of the mechanism is to transmit motion or modify the motion, sir.
Okay, what is the degree of freedom of a mechanism?
Sir, it is 1.
Do you know gear train?
Yes, sir.
What is the degree of freedom of gear train?
Sir, it will depend, sir. In case of this simple gear train or compound gear train, the degree of freedom is 1. But in case of epicyclic gear train, the degree of freedom is 2. Because, sir, in that very gear train, sir, we have a relative motion of at least one of the axis, sir. So for epicyclic gear train, the degree of freedom is 2. But I think in other gear trains, sir, the degree of freedom is 1.
What do you understand by inversions?
Sir, when we this fix different links of a mechanism, sir, it becomes an inversion. For example, sir, if we talk about the slider crank mechanism, when we fix the crank of a this slider crank mechanism, it becomes an inversion of it. That we can, for example, sir, actually, sir, mechanism as such doesn't have any use. But when we talk about inversion, it becomes useful to us. For example, sir, when we this fixed crank of a this slider crank mechanism, we can use it for this quick return motion mechanism, or if we fix the cylinder of the slider crank mechanism, we can use it for reciprocating engine or in reciprocating compressor, sir.
Okay. Do you know what is the mechanical advantage?
Yes, sir. Sir, mechanical advantage is it is actually the ratio of output torque or output force to the input torque or the input force, sir.
Tell me something about toggle mechanism.
Sir, toggle mechanism, sir. At toggle mechanism, sir, we assume the mechanical advantage to be infinity. Sir, actually, what happens, sir, if we talk about this crank rocker mechanism, the toggle position or the toggle position is achieved when there is locking of the chain. That is the sir, the angle between the crank and the coupler becomes 0 or 180. Sir, at the when the locking in the chain occurs, the output force is very high as compared to the input force. Sir, and this means, or other sense, we can say the mechanical advantage becomes infinity. Sir, this we use in case of stone crushers, sir, or in bulldozer, sir, this toggle mechanism.
Okay, so now if I ask you about the instantaneous center, what do you understand by that, Muzaffar?
Sir, actually, a body can have, sir, both translation as well as rotational motion. Sir, for example, if I assume a center about which a body can have a pure rotational motion, sir, that center is called the instantaneous center. Sir, it is significant. Its significance is that, sir, it can help us to calculate the velocity at any point at any instant of the link, sir. At any point of the link at any instant, sir. It is used to calculate the linear velocity.
Okay, so can you tell me ladder में instantaneous center कहाँ पे होता है?
Ladder, sir, if it is inclined at the this, sir, I think since it is sliding, So, sir, for a slider, sir, we consider the instantaneous at infinity. Sir, if we have a like this, and the ladder is kept this inclined, then at the upper part we will the instantaneous center will be infinity, and at the lower end also the instantaneous center will be infinity. The two lines at which these two meet, we can consider that point as the instantaneous center point. Sir, can I draw it on paper?
No, leave it. It's not required. But if I give you a car on a highway,
Yes,
where will
sir.
be the instantaneous center of the car and of the tire?
Yes, sir. Sir, if we talk about the car which is in motion, sir, since the Earth is rotating, sir, so it has the rotational this angular this velocity. So, sir, we can consider the car is in motion. We can consider it in pure rotation with respect to the center of Earth, sir. But if we talk about the tire of the car, then the point of contact becomes the instantaneous center, sir.
Okay, good. So let me give you the feedback. Muzaffar, see, your theory of machine knowledge is okay. I mean, you are reading it, but go for some more technical snaps with me. Whatever a question I
Sure,
asked
sir.
you were giving good answer, except obviously a little bit confusion here and there. Don't you worry, but the rest I found is good. थोड़ा और रिवाइज
Thank you,
करते
sir.
रहो so that next time I go for mechanical vibration part of it. Mechanical vibration
Sure,
का
sir.
एक मैराथन पढ़ा भी है, उसको go through कर
जी
लेना
सर,
आप.
जी
And
सर, मैंने
rest
देखा
I
एक
think
बार, मैं फिर से देखूंगा सर।
ठीक
जी
है मुजफ्फर, गुड नॉलेज.
थैंक यू सर,
थैंक यू.
थैंक यू।